Assalamualaikum warahmatullahi wabarakatuh and hello. So in this video, we will present about our final project. And my name is Izul Syahmi bin Ismail and my group member is Irfan Lai bin Ruiflai. So, okay, the question for this final project is us to design the 2-bit adder circuit in multisim using the logic IC that we have learned. Show the step of design the circuit and do the measurement for any possible input of the circuit. And we need to record all the reading in the table, and we can use any extra electronic component. So before we design the 2-bit adder circuit, at first I will explain about two things, which is half adder and full adder, because these two combination that we will use in our final project design circuit. So at first is half adder. As you can see in the figure shown, this is half adder. Half adder is a combinational logic circuit which is designed by connecting one XOR gate and one AND gate. The half adder circuit has two inputs, A and B, which add two input digits and generate a carry and a sum. So for the truth table is if two input A and B is 0, the output sum and carry will be 0. If one of the input A and B is 1, the output of sum is 1 and the carry will be 0. But when the both of the input A and B is 1, the output sum will be 0 and the output carry will be the 1. We go to the second is full adder, and the example is as shown in the figure. Full adder is the circuit which consists of two XOR gates, two AND gates and one OR gate. Full adder is the adder which adds three input and produce two output, which consists of two XOR gate, two AND gate and one OR gate. The first two inputs are A and B, and the third input is an input carry as C in. The output carry is designed as C out, and the normal output is designed as S, which is sum. Okay, so for the truth table, when the input A, B and C in is 0, the output sum and carry will be 0. But when one of the input A, B and C in is 1, the output sum will be 1 and the carry will be 0. But when two of the input A, B and C in is 1, the output of sum will be 0 and the carry will be 1. But when all of three input A, B and C in is 1, the output sum and carry will be 1. And I will pass to Irfan Lai to explain about the 2-bit adder circuit.
So using our own creativity, we'll be able to create 2-bit adder circuit, which is this circuit here. And the component that we're going to use is basically using our own creativity, we'll be able to create 2-bit adder circuit, which is this circuit. And this circuit is a combination of half adder circuit and full adder circuit, and it will become 2-bit adder circuit. So what are the components that we're actually using? We're going to use 3 times of XOR gate, 3 times of NAND gate, 1 times of OR gate, 4 times of switch, 3 times of probe as our indicator to know how is the output, 1 times of VCC as our source, 1 times of ground, right? So this will be our circuit. Then let's go to the multisim, which is the place that we actually create this circuit, right? So in this circuit, as we can see, it consists of the half adder, which is the top part, and the full adder, which is the bottom part, and we combine them together, become 2-bit, and we become 2-bit adder circuit. And we have the probe on the very right side top corner. We have S1, S2, S3. So this is basically to determine the output, which is either to be 0, either to be 1. And this switch will be the input where we can set either to be 1 or 0, right? So In order to demonstrate how this circuit actually works, we're going to take a look on the table truth that we actually obtain from our circuit, right? So let's say the very bottom one, which is input 1 1 1 1, right? So go to the multisim itself, let's run, right? As you can see, all the circuit is on 1 1 1 1, right? So how is the output looks like? The output seems to be light light no light, which is 1 1 0, right? So if you take a look on the truth table, 1 1 0 exactly. So how this thing is actually works, let's explain in more detail, right? So going back to here, it will be more easier if we have the picture and we're going to explain. Okay, so I did a quick snipping tools here. Okay, so what gate we have here? We have XOR gate, and we have AND gate, XOR gate, AND gate, XOR gate, AND gate, and OR gate at the end, right? So as we know, XOR gate, how does it function? So I did gather few photos here. Okay, so as we can see here, this is XOR gate, and as we can see, if it's 0 0, then will be 0. If it 1 1, then will be 0, and if it's 0 1 will be 1, and 1 0 will be 1. Basically means that if it's the same, then the output will be 0. If it's different, then the output will be 1. Just that simple, right? So let's do this. Okay, XOR gate. So let's say here, all here are 1, right? Because we close this switch, 1 1 1 and 1. Let's go again here. Okay, 1 go to the XOR gate, so this will be 1, right? And this one also 1 1. So when XOR gate is 1 1 the same, then output will be 0. And let's say here as well, 1 1, so this will be 0. Okay, next we go to the AND gate. So how AND gate is actually function? Let's go AND gate. If it's 0 0 will be 0, 1 1 will be 1, 1 0 will be 0, 0 1 will be 0. Basically means that if there's 2 0, then will be 0. If there's a difference, still 0. The output will be only 1 if the input both are 1, right? So very simple. So let's take a look at this. Okay, so here, okay, we have 1 1 1 1, right? So what is the output going to be? 1 1 equal to 1, right? 1 1, just that simple. Okay, so what next? What next? So we're going to go down, which is this 1 1, go to all the way down here. This will be 1 as well, and then this 0 here will be 0, go down here will be 0 as well. Okay, so and this as well. Okay, 1. Okay, so for XOR, right, we know that if it's 0 1, then the output will be 1. And AND gate, we know that if 0 1, then obviously the output will be 0. So from here, output 1 go to OR gate will be 1 here, right? So let's take a look at OR gate. How does OR gate actually operate? So here, if it's 0 0 will be 0, if it 1 1 will be 1, if 1 0 will be 1, 0 1 will be 1. So basically anything will be 1, unless if its input both are 0, then output will be 0. Okay, so at here 0 1, what is it going to be? Of course it's going to be 1. Boom. So going up, okay, 1, correct, right? Here 1, here 1, correct, here 0, here 0, correct. So that's how we get the output, and so on, right? We have a lot, so that is just the example. We take the only last row. Okay, so that's how it works.
Okay, that's all for our final project. Thank you.